Hello, my name is Lena, and today I would like to present my econometrics project about Titanic. I'm sure that many of us has watched the film of James Cameron and know how it has ended, but not many of us really know why Rose survived and Jack didn't. So let's discover the reasons of this unfortunate end by using machine learning and statistics basics. For the beginning, let's remember the true story. One of the reasons that the shipwreck led to such loss of life was that there were not enough lifeboats for the passengers and crew. Although there was some element of luck involved in surviving the sinking, some groups of people were more likely to survive than others, such as women, children, and the upper class. This challenge I have found on Kaggle competitions, and here I am asked to complete the analysis of what sorts of people were likely to survive. In particular, I was asked to apply the tools of machine learning to predict which passengers survived the tragedy. So let's discuss our data. Here I had two datasets, for training the model and for testing. The dataset for training has 12 columns with such information about every passenger. Passenger ID, just to identify his or her uniqueness. P-class, which had values 1, 2, or 3. It describes where the passenger was situated. As you can guess, the first class was for rich and noble people, second for middle class, and the third one for ordinary mortals. Besides, I knew names of each passenger, sex, age, number of siblings or spouses, means husband or wife aboard the Titanic that was mixed together, number of parents or children aboard the Titanic also mixed, ticket number, passenger fare, that means how much each passenger spent aboard the Titanic, cabin number, port of embarkation, and dummy variable that describes whether a passenger survived or not. The structure of test data is almost the same except for the last column, which indicates whether the passenger survived or not. Here it is missing. For this dataset of passengers, we have to predict their outcome. But before building cool models and prediction, we have to clean and format our data for further usage. For convenience, I changed data types of some variables. For example, I converted some columns to factor, like sex and port of embarkation, for later turning them into dummy variables. Besides, I converted name and ticket number to character. Some information for some passengers was missed, like age and fare. I decided to fill the age with a median of age according to sex, because basically aboard the Titanic, men were older than women, so I have to fill missing values carefully and separately. For filling missed fare of passengers, I built a decision tree to define according to the rest factors how much the passenger could spend aboard the Titanic. For filling missed variable, you have to look at the rest information about the passenger and try to define how much could he or she spend. For example, Mr. Thomas Story was in the third class, so he could spend approximately $15. If he was in the first or in the second class, we had to go on the right to decide how much could he spend. Now, let's do some visualization for better understanding the data. The first plot shows us how many people from the trained dataset has survived and has not. The second one is more interesting. It shows us who survived and did not survive according to sex. As you can see, there are more survived women than men. I think that men were noble enough to let women go ahead, and they could be saved first. And the next one is about surviving according to your class. As you can see, there were more people from the first class who survived since after the disaster they were evacuated first, and they lived in the cabins that were closest to the upper deck, where the evacuation took place. As for the non-survivors, of course the most deaths were among the third-class passengers. Most likely this is due to the fact that they were not in priority during the evacuation, and moreover, their cabins were below all. So when the ship collided with the iceberg and began to sink slowly, their cabins were flooded first. Speaking of cabins, in my table there were little data on the cabin number of each passenger, so unfortunately I could not take this data into account when forecasting. However, as I mentioned earlier, the class of the passenger is a fairly accurate variable to indicate the place of each passenger on the ship. But that is not all. Here is the histogram of age. As you can see, there were many young passengers and mode is 28 years. Here is a plot of survivors according to number of siblings, spouses, and parents' children. At first sight, I can't say that there is a big difference whether you were lonely aboard the Titanic or not. For example, there are many lonely people that survived and did not survive, so I don't think that that's a very important variable, and I will check it later. And also I think that the histogram and the variable of how much each passenger has spent aboard the Titanic is not important. I will also check this later. Finally, we can build a model. My first model was logistic regression because the answer which we want to get is a dummy variable. Could passenger according to all data survive or not? Of course, I did not include such data as name, ticket, or passenger ID. It means nothing for model, but the rest that I mentioned before were included and you can see it. You can also pay attention that I turned sex and port of embarkation into the dummy variable. And now let's see the estimates. Remember that we do not pay attention on intercept. So it seems that gender, class, and age played a key role in the surviving of each passenger according to p-value. More insignificant factor is whether you had a sibling, spouse, or not. All other variables have much larger p-value than the previous four, and we will see it one more time later. As you can see, the class has a negative coefficient because the lower the class, the less chance. The same tendency has the age and number of spouses. If you were older, you had less chance. If you were not alone, likewise. I explained the reason for these estimates of class and gender earlier, but as far as age is concerned, I think everything was quite simple here. Firstly, young people could orient and escape faster than older ones, and if a person was less than 18, others could save him/her first, since women and children were in priority. Now, let's do some variable selection and test whether it will give us more precise model. I used caret library to try variable importance function. It shows us that the number of parents' children, fare, and ports of embarkation are not important. Their coefficients are almost zero. In order to be sure, I performed the likelihood ratio test, which compares the likelihood of the data under the full model against the likelihood of the data under a model with fewer predictors. Given that null hypothesis holds that the reduced model is true, a p-value for the overall model fit statistics that is less than 0.005 would compel us to reject the null hypothesis. It would provide evidence against the reduced model in favor of the current model. However, you can see that p-value is much more larger than 0.005, so we cannot reject null hypothesis that reduced model is better. So now let's try to use reduced model. Now I am doing partition of data to build a model based on first part of trained dataset and then fit in and define its accuracy by testing at the second part of trained dataset. It can be said that this is a rehearsal before full testing of the model and an attempt to predict, but now we still use trained dataset because here, unlike the test dataset, there is a column about the information whether the passenger survived or not. That is, we can compare the accuracy of the forecast with real data. You can see that we have got the estimates with the same sign of plus and minus as before. Now, I will try to predict the outcome for each passenger for the second part of test data and compare the results using confusion matrix. As you can see, we were right in 279 cases. The accuracy of such prediction was 78.37%. Can we do better? Let's try. Here I try to build random forest model and try to see whether it will give me better results. Random forests builds multiple decision trees and merges them together to get a more accurate and stable prediction. After successful building confusion matrix, you can see that random forest is a bit better than the logistic regression here. That does not mean that random forest is always better, but in this case it gave us more precise results. We were right in 288 cases, and the accuracy is 80.9%, almost 81. Congratulations! So, what about making some conclusions? Well, the competition for me was very interesting, and the result that I got at Kaggle was 76.5% of accuracy. After all of this work, I have studied and understood many interesting and useful tools for prediction and rating because I am not such kind of person who can understand this from theory part. Datasets have many variables, some of them were important and some not. We dealt with it by using common sense and variable selection. Besides, we filled missing data with median and decision trees, built two different models and compared the results. Actually, at the first sight, I was a bit disappointed that great number of variables were not important. The big surprise for me was the variable that describes number of parents and children, but then I thought that it would be much more interesting if number of parents and number of children aboard the Titanic of each passenger were separated, because I'm sure that if you have child and parents that are in danger, you would rather sacrifice yourself and save your children than parents. Oh, by the way, I did not say why Rose survived and Jack did not. Because, as you can see from both of our models, people who were more likely to survive were rich, young, or females. I think that I can't combine these factors together, so I cannot state properly that Rose survived because she was a young and rich woman. She survived because of something that you cannot measure by statistics: love. Sorry guys, there is still something that we cannot measure, and that is something that inspires all of us. Thank you very much for watching this video till the end. If you like this video, press like. If you are my professors, give me 30 points for the project please, I tried very hard. Bye, see you at the exam!